Hey guys, so in our last video we talked about method of joints, and our number one qualm with the method of joints was what? It was really cumbersome, right? Because it is easy, but it's a lot, and depending on what they're asking you for on the exam, you probably don't want to do all of that with your time. So here's a method that can cut your time in half. Method of sections. Okay, so this method is actually really cool, similar to method of joints. However, this one's a lot less cumbersome. So this is the truss from our last video, and rather than asking us to find the forces in each member or looking at each joints, we're only asked specifically, and on the exam you're going to be asked specifically for certain members of the truss, but we're asked here to find the force in member BC, in member CF, and in member CE. So what we do, first things first, is to cut it. So how you see right here, I'm going to draw a line between every single one of the members of the trusses that we're looking for. Now you look at the entirety of the thing and you ask yourself, which side is going to be easier to solve? Which side is less complicated and has less variables? After you choose a side, after you pick a side, you have to draw a free body diagram, and I would honestly advise you to draw as big as possible, as big as you can, and as detailed as you can, as detailed as it is on the truss, so you don't miss anything that you're going to need for your calculations on this part. Because although it's easier to make mistakes, unlike with the section of joints, because that one is just a lot of cumbersome work, but it's piece by piece by piece. This is just taking the entirety of a section and trying to solve for whatever members that they're asking you for. Now, before we do anything, you have to check for our supports. We talked about it in our last video. So the most likely supports you're going to have on the exam is going to be a pin joint or a rolling joint. A pin joint has a reaction on the X and Y axis, while a rolling joint only has a reaction on the Y axis. Why is that? Because a rolling joint moves on the X axis. Although I didn't mention this in the last video, you're always going to assume tension whenever you're solving for these. The reason why is so you remain consistent. It doesn't mean that if you don't assume tension, you're going to be wrong. If you assume tension and when you get your answer at the end of the day, it's a negative answer, then you know that it's compression. However, you can assume compression, and if you get the opposite answer, then you know that it was actually in tension. So it's not a big deal. But in order not to confuse yourself, whether on the exam or whether you're just doing regular calculations, I would advise to always assume tension. So for the actual solving part of these questions, most of the method of sections questions is just basically testing out what we've already done in statics so far, right? So our resultant forces in our sum of forces in our X, sum of forces in our Y, a moment of our whole system. So basically the reason why you're going to be able to use these to manipulate and get your answer is because when we cut our beam or we cut our bar, we're actually going to, that internal force that we were solving for in method of joints is no longer existent, because now that we've cut it, it's actually similar to an outside force. So that's why you can use the equations that we use for outside forces, or that we used when we were looking at each joint. Now we can use it as a whole, because when we cut that beam, that force is no longer an internal force. Okay, so I'm talking too much. Let's just get into the problem. I'm going to do the problem we did the last time, but I'm also, not in this video, but in other videos, I'm going to do more method of sections problems and more method of joints problems, just so we can get it like